Okay, question 10. What is occurring? The gradient of a tangent to a curve, basically dy by dx, equals 3 cos of 2x. Happy days. The curve goes through a special point that looks incredibly messy. Find y in terms of x. Find my original equation, knowing that this is its gradient. So, to get from the equation to the gradient, I would differentiate to get this. To get back from this to the original equation, I'm going to integrate. So my first job to do this, y is going to equal the integral of 3 cos 2x dx, and you're going to get a mark for doing this already. Now I have to figure out how to integrate this. And I mean, the easiest way, let's just break it down slightly. If I was going to try and integrate cos of 2x, then the game is, what is it that I would differentiate to get this answer? So what I'm going to do is guess using kind of magic powers. You can actually know, there's a better way. You can look on the formula sheet, to be honest. The answer to this is more or less at the bottom of the formula sheet. But essentially, if I had y equals sine of 2x, I would differentiate this using the chain rule, and I'd get sine goes to cos of 2x, the same thing, and then I would have times by 2, which I don't have. So what I'm going to do is have sine 2x over 2, and it's the same as how if I'm integrating, say, x squared, I end up dividing by that 2. Okay, so integrate that, integrate x, let's say, then what happens, I get to x squared over 2. So in the same way, I've ended up doing this, basically. So here is my answer, and the reason is that if I differentiate this, sine of 2x gives me cos 2x, and then the halving bit cancels out with the 2 that comes out of this. Differentiate that to get 2. Now, here, I want an extra 3 multiplied by my answer, please. I'm going to have, therefore, an extra 3 multiplied by my answer here. So 3 over 2 sine 2x. There you go. Now, the problem is that's not the answer because there's the plus c to deal with. And what on earth is c? Well, we're going to find it out using this. So, we know that when x is that, y is that. Sorry. When x is that, y is that. So let's just go ahead and sub that point in here to work out what c is. So y is going to be root 3. Okay, let's just do that. Y is going to be root 3. That's going to be 3 over 2 sine of 2 times 7 pi over 6. They make it easy, don't they? I mean, plus c. Right. That's 3 over 2 sine of, now what goes on here? I can cancel out that, right? So I've got sine of 7 pi by 3 plus c. And now I'm just like, what on earth is sine of 7 pi by 3? Well, who only knows? I don't know. Let's work it out. So 7 pi by 3 is like having 6 pi by 3 plus 1 more pi by 3. That bit, that's like having 2 pi plus pi over 3. Okay. And 2 pi is actually like 360 degrees, like that's where I get back to the start. So if I were to draw my sine graph that goes wibbly wobbly wibbly woo, right? 360 is here, where I get back to the start of the whole thing. So 360, or in this case 2 pi, okay, plus another pi by 3 is going to be here, pi by 3 further on, okay. Pi by 3, what's that like? That's like 60 degrees. Why? Because pi is 180, divide it by 3 and you get 60. So really my question is, what's this here at 420, at another 60 after there? And it's the same as just what is sine going to be at 60 degrees. And the answer to that is root 3 over 2. Okay, so, sorry about the light. what's going to happen is that this bit is root 3 over 2. So I've got root 3 is 3 over 2 times root 3 over 2 plus c. Okay, right. Root 3 is going to be 3 root 3 over 4 plus c. It's getting closer, isn't it? It's times by, this one. Okay, that's going to be 4 root 3 over 3, over 4, my bad. 4 root 3 over 4, same as just root 3, is take away 3 root 3 over 4 is going to be c. Do that and I'm left with just root 3 over 4 is going to be c. Excellent. Right. So my final answer, I already knew it here basically, but I had to figure out what c was. A load of mess to get to that. So my final answer at the end of the day, let's put it in a big fat circle. Y is going to be 3 over 2 sine 2x plus root 3 over 4. There we go.